Welcome back, friends, and thanks for joining us once again. Today we're discussing water heaters. This video is a lot of fun to make as we got Brian in on the action and we went ahead and left some of the outtakes in at the end of the video. We're constantly striving to improve the content that we are putting out in order to better serve our existing clients, future clients, other inspectors, as well as our real estate associates. If there's a topic that you'd like us to dive into and discuss, let us know in the comments. Lastly, if you find value in what we're doing here at Guided Inspections, be sure to share with your friends. We do appreciate your support. Hey everybody, back with another video today. Today we're doing a component inspection video. So we're going to be taking a look at a single part of our full home inspection and kind of breaking it down a little bit and discussing what it is that we're looking for in the way of deficiencies, safety items, and those types of things. So what are we looking at today, Brian?
So we're inspecting the water heater in this house, and we're just going through the different components and making sure that it functions properly, kind of going through our checklist.
So we're gonna knock that out.
So one of the first things that I do when I inspect the water heater is I get a picture of the data tag. So we're looking, per our trick standards of practice, we have to note what's the energy source and what size is the water heater. So obviously here we have gas and we have a 40-gallon tank. Not specifically to our standards, we also note the age of the unit. So that's the first thing that I do before I inspect anything is I grab a picture of the data tag and I note all those things. Okay, so right now I'm checking the draft hood, making sure that the escutcheon ring is good and tight and that there's proper clearance for the B vent. It's not uncommon that these draft hoods are loose and unsecure, so I just gotta make sure that it is secured there. I'm also checking for the cold water shutoff here on this line. I'm also checking for rust, corrosion, or leakage up here and making sure that everything is good and tight. So I see a little bit of corrosion here. It doesn't look too bad. I don't see evidence of active leakage, so I may put it in the report as an FYI. So we're looking as well for a thermal expansion tank. We won't see them so much in older homes, but in new construction homes, we're looking for them if it's a closed plumbing loop. The reason why thermal expansion tanks are required on closed plumbing loops is because as water heats up, it expands, and the thermal expansion tank allows that to alleviate some of that pressure.
Okay, so another portion of the water heater inspection, in this case we have a gas unit. We're either gonna have gas or electric. There are some heat pump water heater systems which are primarily electric, but they have an added heat pump design for efficiency. We don't see a lot of those, but in this case today, we've got a gas water heater. So our gas valve comes out of the wall. First thing we're looking for, proper shutoff valve. So this shutoff valve here, we've got the handle stop. It's in the right position. We know the gas is flowing. Everything looks good there. It's secure, no visible damage to that valve. So we've got our gas valve in place and everything looks good there. Now during the course of the home inspection, we do not turn these valves on and off generally. There's some cases where we get to a property and the gas may be off, new construction, it's not uncommon. And as long as we've checked everything else, we might turn that on to let it go. But as a normal course of testing, we do not test and operate that valve. In some cases, we have older valves, and by testing that, we may damage that valve, and now we have a situation on our hands. But beyond the valve, the next thing we're looking for is what we call a sediment trap. And that's this little extension of pipe right here. And a sediment trap is essentially designed to be a receptor or a portion where any debris that might be in this gas stream will hit here, do a change in direction to come to the gas valve. At this point, any of that debris or anything that's heavier than air is going to fall down into this sediment trap here. And it has to have a cap at the bottom so it can be removed for servicing and cleaning. What we'll often find is the gas flow will run across and the sediment trap tees down. Well, that's an improper trap. There's no change in direction. Here we have a proper setup, change in direction, connector coming into the gas valve. Connector looks good, it's secure. And at the gas valve here, we've got our gas supply going into the burner, and then our thermocouple tube. This senses the flame and tells this valve that it's okay to continue releasing gas. So as we're inspecting these components, we're also kind of smelling to see if we can smell any gas. Natural gas, propane, they all have an odorant added to the gas that will allow you to detect the presence of a gas leak. And sometimes if we smell a slight hint of that odor, we'll investigate further. We'll get our gas detector and we'll start checking all our connections. Anywhere where we have a threaded connection, we'll even check along the pipe. Sometimes there may be a pinhole leak somewhere in the pipe. Also, we'll check under here where the gas tubing connects to the gas valve itself. All locations where we could have a potential gas leak. All right, so this one looks good. Didn't have an odor initially, but I figured we'd check it out anyways. Looks good, not getting any gas detection on this unit.
Now we're going to inspect the temperature pressure relief valve, and we are just making sure that it does operate, that there are no leaks. I'm looking for any rust, corrosion, and just making sure that it is going to safely remove water if the water exceeds a certain temperature or pressure. Now that we operated it, we're going to follow the line, go outside, find out where it's terminating, and make sure that's proper. So this is where the TPRV is terminating, and we're just making sure that it isn't 6 inches or higher for a potential scalding hazard. We're also making sure that it's not dug into the ground, that there is a little bit of clearance, so we're avoiding blockages. Usually we try to identify this first when we're doing our initial perimeter check, our exterior walls check. We find this line and we make sure that it's not leaking, so that when we do go to check the TPRV valve, that we can see that it has drained properly and it's doing what it's supposed to do. So towards the end of the inspection, we're going to come back around and we're just going to make sure that this has stopped dripping.
So since we do have a gas water heater, one of the things that we need to make sure we have in place is proper combustion air provisions. So with this unit having a solid door that closes, this is going to be an enclosed space. So it is required to have combustion air brought in from the exterior. So our combustion air for this unit is here in the back corner. We've got these two, look like 4-inch ducts. Our upper combustion air duct is roughly 12 inches from the ceiling. And then our lower one extends down and it terminates approximately 12 inches from the floor of the water heater unit back here. These ducts here are serving this unit well. We do have the proper upper and lower. Sometimes we'll have both of them up high or both of them down low. We might not have any at all, or one small one. In a lot of cases in older existing homes, this whole entire ceiling will be gone. This is a best case scenario we can hope for. There are specifics regarding combustion air ducts as far as what type of material can be used. So technically maybe these could be a rigid material, but in this particular case, especially on an existing home, we like at least seeing what we've got here. This water heater is not going to have a problem with combustion and dilution air getting into this. These ducts, by the way, extend up into the attic. They have to extend at least 12 inches above the insulation level because they cannot be screened, but we also want to make sure they're not going to be clogged with insulation. One of the reasons why this is so important for a gas water heater If you look here at our exhaust vent, we have this draft hood. This is a natural draft water heater, meaning there's no fan to induce a draft. There's no sealed combustion. It's all natural draft. So as the water heater burner is burning at the bottom, that heat rises through the inner flue and hits this vent pipe here. This vent hood, or this draft hood rather, is to take in air and allow that to draft out properly. As this flue heats up, it creates a chimney effect and it will draw the exhaust gases out. If we don't have an air inlet portion, it won't exhaust properly. And then this area will fill with the combustion byproducts, and carbon monoxide can be an issue for this home. All right, so now down here at the bottom, we're looking at our drain pan. The emergency drain pan is required for any water heater where if leakage were to occur, it can cause damage to the structure, the interior finishes, etc. Water heaters in garages, as long as they're elevated properly, don't necessarily need a pan, but here in this case, where we have it in a closet within a laundry area, we do need the pan. Gas water heaters, metal pans only. Sometimes we'll see plastic water heater drain pans, and they're okay for electric water heaters only. In this case, we need metal, and we have that. The one thing we are lacking on this particular unit is an effective drain for this pan out to a proper location. Now, in this case, our water heater is in a closet in an interior space. That drain would effectively need to be routed over here to this wall and punched out, which is into the garage there. If the seller or the home buyer can reroute this drain to terminate in the garage at the lower floor, then that would be an effective routing of the drain for this pan. This is one of the issues with replacing a water heater in an older home where when the original unit was installed, they didn't always put these drain pans in. Now that they're a requirement, we have to put it in with the new unit, but in order to get that to drain properly outside or to the garage, we kind of have to get creative with our drain line. So that covers a lot of what we're looking at for water heaters, between the combustion air, the gas lines, if it's a gas unit, pressure relief valve, drain pan. All those things we're looking at to make sure everything's proper. It's interesting because all that we're looking at and all those details we're looking at, we generally can look at from top to bottom and conduct that water heater inspection in just a matter of minutes. But there's a lot that we're looking for. As a minimum, we're looking at this from our standards of practice, which necessitate what we have to call as a deficiency. But as per usual, standards are our minimum guideline. We're looking at a lot of different things, and if we see something that isn't necessarily in our standards, but we feel could pose a problem to our clients, we're gonna make a note of it in the report. Thanks for joining us today. We hope to add some new components of our inspection. We can start covering electrical panel boxes, the branch circuits throughout the house. We can look at HVAC systems. We're getting close to 100 subscribers, so if you guys are finding value in these, share them with your friends, your network, and let's get to 100. Maybe we can do a subscriber giveaway. So I'm Jesse.
I'm Brian.
Guided Inspections. We hope to see you on the next video. We can start doing some and from there we can look at maybe doing I can't say subscribers. Maybe you could say that part, Andrew.
If we get to 100 subscribers, you're going to be part of an exclusive
right.
club.
It's okay.